AI tools also. Still, you are not sending resumes. Okay, then what I understood, if you're not sending resumes, you make clear. So not required any help resume point of view. Okay, very good then. So Saturday, Sunday also done 3 days holidays for me, but I got only 4. And if anyone share working days, wait till 1 week to get reply from my end, especially for resume. Okay. Yeah. Let's get started. So tomorrow onwards, I'm going to start Azure. So today, I will. Hmm? Okay, no problem. I mean, if you need any suggestions, only you can send it to me. Otherwise, no problem. No need to send it to me. Just I'm saying, if the resume is good or not. If you still having any questions, yeah. Otherwise, internally we have divided teams, right? Internally, you can take your TL reference or your team member reference or already working people reference. You can take it. Anything is fine. Okay. Okay. So the concept is just as I said, I'm going to give introduction on Docker. So understand very carefully. This Docker introduction is very important to understand what is Docker. And again, Azure classes will start from tomorrow. I need to create account actually. I stuck there only. So maybe I will share new link tomorrow from tomorrow for Java. Sorry, Azure. Okay. Maybe this link may not work. I don't know. I'll confirm in the Telegram group. Please be active in the Telegram group. Okay. Yeah. Maybe others also can join. I don't know. Need to check with management. If the link may change, please keep an eye on the Telegram group. Yeah. Docker. Just we can discuss what guys. Yeah, classes. See, no disturbances from your end. 9 a.m. is common. Timings are common. No changes. I have attended 3, 4 interviews recently. Everyone asked me Docker and Kubernetes. I told you, na. I told you, right? Docker Kubernetes is very important. Terraform also very important. Yeah. So please join every day in time class and offline students. Please come to offline. Not easy to understand Docker and Kubernetes through online. I mean, freshers, career gap students. I'm saying. Experience your wish. You can attend from anywhere. Okay. So tell me, guys, what is Docker? Again, no recap after Azure, Docker, no recap for day one. Again, one more time. Focus now only. Write in your book if you want to write. Tell me what is Docker? Wrong. Docker is not an orchestration tool. Orchestration also there, but not. Basically, Docker is not orchestration. Docker is what? Containerization tool. What is containerization? What is containerization? This is day one of Docker, okay? Day two will again start after 1 week. If I say day one class, you need to remember what I'm going to. So guys, you tell me, this is physical server. For example, can I divide this physical server into multiple VMs? One physical server, can I use like multiple VMs? Yeah. By sharing what? Hardware resources, right? OS we can take from external. Right now we are creating VM means you are creating VM, right? AWS EC2 is what? VM only. The background physical hardware and all taken care by AWS providers, not you. So in this case, okay, let me divide one server into three servers, for example. Clear now? One physical server into three VMs. Just for understanding purpose only. And here, VM1, okay, VM1, VM2, VM3. This concept is what? Physical server to VM creation process is what? Very good. Virtualization. Clear or not? Then you know everything, then Docker is very easy for you. Learning Docker Kubernetes is also a good art, you know. It's not easy to everyone. To learning Docker Kubernetes is not easy to everyone. Still, if you learn means you have a good future. So Docker Kubernetes always coming 15 years, 10 years, always there. So maybe the background orchestration changes will come, but Docker Kubernetes, if you are strong in Docker Kubernetes, your future is good, I can say. Your future. Docker Kubernetes is your future. Virtualization. Okay. In this case, my end, okay. In this case, what I'm trying to say, my end, only one application is there. Only one application. I want to deploy one application. In this case, I'm not talking about at this time high availability and all. If one application I want to deploy, which process I can take now? Maybe one server is enough, right? So three VMs are not required, right? Then I can deploy here one server, either physical server or this is also cloud server. One server is fine. Okay. So in this case, anyone attended the session on Saturday here from here? How many of you attended? Anyone attended from offline? 1, 2, Saturday session, not 9 a.m., evening session. RDS backend connection, attended? Understood? The session is? Okay. Good, good. Yeah. So we can easily write a code also, guys. We no need to focus, see backend how the API methods will work. I will share the recording also, don't worry. If anyone miss, I'll share the recording also. Yeah. Guys, okay. This is approach number 1. I want to deploy 3 applications. Now, which process? Virtualization. 3 virtual servers are there. So means your end 3 applications are there. You can create 3 EC2 instances. So virtualization VM1, VM2, VM3. The background VM1, VM2, VM3 resources will provided by AWS. That means physical resources. We no need to take care, right or not? So in this case here, app 1. Carefully observe what I'm saying. App 3. Okay. Now, how many servers I need to create in AWS? Huh? Tell me. 3 servers. 3 applications are there. To deploy 3 applications in AWS, how many servers I should create? 3 servers. If I need high availability, 3 into 3 or 3 into 2 or 3 into 6, it will increase the number count, right? This application I need high availability means what? You need to create one more server, app 2, one more server, app 3, one more server. Like that we can increase the servers count. Clear or not? Okay. Now, I want to deploy 100 applications. 100 applications. I want to deploy now 100 applications. Now, can I create 100 VMs? You are saying 3 applications, 3 VMs. Okay. 100 applications. Yes, you can create 100 VMs. If you create 100 VMs, I mean 100 EC2 instances, if you need high availability, 100 into 3, 100 into 3, or 2 or 4, 400 servers minimum create. Minimum 200 servers, max we don't know, depends on the traffic, each application traffic. How many load balancers, how many auto scaling groups? 100 auto scaling groups. Okay, leave it for auto scaling part now, load balancer part now, just understand the server point of view. Minimum 100 servers are required for 100 applications into high availability. Depends on a minimum 2 or 3 or 4, the number will increase, not decrease. Okay. But now, this is what it will create an impact on cost, right or not? Not only cost, how difficult if something is issue is there to identify the server, to manage the infrastructure, to root cause and all, it's very difficult or not? Managing 300 servers, 400 server, which server issue is there to identify, it will take 1 or 2 hours. So managing is very difficult if number of servers increasing also along with the applications. In this case, what we can do, we can use containerization platform. The difference between containerization, virtualization, only size, reduce the size. Guess you tell me virtualization time. What is my OS image size? You remember or not? In the demos time, I think I have created virtualization time Ubuntu desktop image. We have taken, right? If I go here, for example, Oracle VirtualBox. If I go here, let me delete, that's what my system is slow. So yeah, if I want to create a one VM on my laptop, this VM shares from my laptop only hardware, right or not? What about OS? This is Windows OS. Then how Linux server will created? Linux server is created. OS I'm not sharing from Windows. OS downloading from where? Google. Right or not? This is Ubuntu VM. In this case, I should download Ubuntu ISO image. Understand, guys? Very interesting concepts. Docker and Kubernetes, that too very difficult concepts, but not for us. Yes, if you ask any DevOps engineer which tool is difficult, first they can say Kubernetes, but not for us. We learn a very good track, the basics, AWS, and our track is very good. Path is very good. So that path will help easily understand Docker and Kubernetes. Okay. Yes, my students Docker Kubernetes is not difficult if they follow my lectures day 1 to day end. You can play with Docker and Kubernetes. I'm not saying play means 100%. 100% no one is, 100% I'm good in Docker and Kubernetes, no one can say. Even I'm also not saying. So many concepts are there. It's never ending process. So it different dependencies, different process. I'm also, I can say 80%. So 100% means if any project will come, you can easily understand first how the project is running. If you are able to understand, you know how to manage also later. That level I will take care. So Ubuntu desktop, minimum size is what? 6 GB. Right or not? Let's understand now slowly. Okay, each VM, if I want to create an EC2 also, minimum 8 GB it will take. Right or not? To run your application. Here also 8 GB. Here also 8 GB. Now, this VM's count depends on what? Your physical resources, physical machine resources. But this is managing by AWS providers. Right or not? So unlimited, you can take this VM size, you can increase the hard disk performance, increase the hard disk performance, increase the hard disk performance. But your hard disk 8 GB to 20 GB, you can increase. They are providing the resources, the background. But this VM is virtual machine on your laptop, not on cloud. Then this VMs depends on your laptop resource. My laptop is supporting 100, for example. You can create 8 GB VMs only 10 or 11. Right or not? Can I create 100 VMs? If you are able to provide resources, yes, I can create. Yes, cloud is providing resources, then you can create. But even creating multiple VMs is not a good practice. That will create an impact in terms of costing, in terms of managing the project. Okay. Now what virtualization is clear, right? What is containerization? Simple logic. See now. So now I need to deploy 100 applications. Instead of creating 100 servers, what we can do, I'm taking one VM only, or I'm taking only single VM. One VM can create 100 isolation environments. 100 means, why 100 I'm calling here? 100 applications. So how one physical server allowed to create a multiple VMs? That means multiple environments. We are dividing logically one physical server into 3 VMs. Right or not? We are dividing into one physical server into 3 VMs. Now, why here? For example, this is a big resources, 100 GB and all. My application deployed only one application. This application only taking 5% resources only. Remaining 95% wasting or not? Right or not what I'm trying to say? In this case, we can divide one physical machine into multiple VMs that can host multiple different applications. Now I can divide into, I can split into multiple VMs. One is Linux VM, one is Windows VM, one is Mac VM, your wish. You can split. Why? OS taking from external. Clear this concept? Same concept AWS also will follow. AWS is follow virtualization concept. Which virtualization? Nitro. Right or not? Separate software. AWS follows. Or Zen. They're using both virtualization concepts. Anyway, if you want VM, you can create the background resources will take care by AWS providers. But I want to deploy 100 applications. I want to deploy 100 applications. In this case, you need how many servers? 100 servers. Instead of creating 100 servers, what we can do? You can go for containerization process. What is containerization? So here I'm not talking about 100. It's very difficult to drag 100 VMs. 10 applications, for example. In this case, I need what? 10 servers. Instead of creating a 10 servers, I can deploy 10 applications into one server only. Okay. This is called containerization. You may get a doubt now. How it is possible 10 servers, 10 applications, how it is possible to deploy one server? Now, 3 applications deploy into 3 VMs, right? That comes from only one physical resource, right? So the count can increase like a tree. Okay, from 1 is to 3, 3 is to 300. Means we are utilizing the resources instead of wasting the resources. So now from this server, I can create 10 isolated, environments inside the one single server only. Okay. So this is one, for example, 2. Okay. So like this. Now see, how many environments are there now? Total 10 to deploy 10 applications. Okay, to deploy 10 applications. Now this 10 environments running inside where? VM2 server only. Let's draw this. The server name is what? VM2, virtual machine 2. Clear now? Clear everyone? This server initially accepts only one application. Now this server able to accept 10 applications. I will give clarity. Just wait. Focus only here. Instead of directly what is Docker, what is something and discuss, just understand here where we can use and all. Clear now? Clear now? Guys, you tell me the number of environments are there right here. App 1, app 2, app 3, app 4. So each environment can call container. Clear now? So how many containers are there? 10 containers. Each container, one applications. How many applications are there? 10. How many containers are there? 10. 10 containers running on where? VM. One VM means one EC2 instance. Now one EC2 instance hosting how many applications? 10 applications. Before only one application. So then this is called containerization. The main agenda, you tell me. My 10 containers, can I increase to 20, 30, 40, 50? Count can I increase? Depends on what? Resource providing by VM2. Clear or not? Depends on VM2 hard disk and hardware. Your VM2 able to provide 8 GB to 80 GB, 10 to 100 you can create. Clear or not? Now tell me, simple logic, slowly I will take you that one concept here. Focus first. Here, now 10 VMs I'm able to create. Okay. I want 20 VMs, sorry, 10 containers already created by sharing VM2. I want 20 containers. I want 20 containers. So here two concepts we need to understand. To increase the containers count depends on what? Resource that resources provided by host VM. Clear or not? In this case, we can increase host VM size, VM resources, hardware, or one more method is what? So try to reduce the size of container also, right? Each container. Agreed or not? So focus, you can put focus on each container as possible to reduce the size. My container size is, for example, 1 GB. Try to reduce it so that we can create one more container. Understand? For example, each container is taking 1 GB, 1 GB, 1 GB. Now total hardware sharing 10 GB. If I create each container is 500 MB, 500 MB, 500 MB. How many containers I can create? 20. Right or not? This is called cost optimization. Container size cost optimization benefit is what? We can reduce the size on host mission, right or not? So, for example, your VM is 8 GB here, but only able to deploy one application only. Same VM 8 GB, now able to deploy 10 applications because of containerization. Okay. Now, you may get a doubt. Okay. What I'm saying, 10 containers and all, how these will be possible? This possible only with Docker. Clear now? So this possible only with Docker. Okay. Let's see now. For example now, how many layers are there in the VM2 server? First layer is what? Hardware, which contains hard disk and all. Hardware. Next layer is what? OS. Next layer is what? Applications. But if you deploy application runs on where? This OS. Which OS? VM OS. VM OS, if you run means, definitely that, see, here I'll show you now. Application runs on where? Directly OS here. Which OS? Your VM operating system, right or not? Your app2 is running your VM2. This is VM2. But instead of running my application on host OS, I will divide my hardware logically by using containerization. That logically containerization divide process, we can get it from Docker. Clear now? So in this case, instead of directly run application on host OS, you can take Docker help first. Tell me guys, my laptop inside, I'm able to create VMs. This is Linux VM only, right? How it is possible? This VM is running on my Windows operating system. This VM is running on my Windows operating system. No. Taking hypervisor, this OS already I have taken from external Ubuntu OS. Clear or not? To run this OS, I need a one layer, right? Which layer it is? Hypervisor. That layer provided by this vendor, VirtualBox. So my laptop to multiple VMs, you see what I'm trying to say. Let's take here. So this is my laptop server, for example. My laptop means server also, right? Laptop also server. How many layers are there? Same. 3 layers. Hardware, OS. My laptop also hardware, OS. Let's take. So please focus, guys. It's a Docker explanation is not at all easy as a trainer also. Make you understand. And now let's take a application. Now your application is running. Now your application running on where? Directly running on where? Which OS? This is Windows laptop means Windows OS. Clear now? But now I want to divide this. This is my laptop only. Laptop means server. You can take it like this. But I don't want to, I want to divide this laptop into 2 VMs. We can't break it, right? Logically you can break it, not physically. How to divide logically? This is your laptop, right? Yes, this is your laptop. First layer is what again? A hardware. Next layer is what? OS. Which OS it is? Windows. Now, carefully observe this point now. Now, I want to deploy two applications. One is Windows application. One is Linux application. I want to deploy these two. In this case, this process is not suitable, right? Only this process suitable for Windows application as application running on directly Windows OS. If you deploy Linux application here, not work. The reason Windows OS this is. Clear or not? Okay. In this case, I want to deploy Windows application plus Linux application in single server. Then what I can do? I need to divide this laptop into two laptops. Half laptop is Windows, half laptop is Linux, like that. That process you can do with the help of is what? Virtual machine. In this case, you need to take OS from external, right? That OS, how many VMs required first for this on these two VMs? I'm dividing into two parts, right? Clear now? Again, each VM also three layers, right? Hardware, OS, hardware, OS. This hardware shares from where? Host server hardware. This VM hardware shares from where? Host hardware. Clear or not? What about OS? If OS will share, this two VM should run on Windows only. That's what virtualization concept, not share any OS, only hardware. Then this OS takes from where? By internet, Google. So if you need Ubuntu OS, if you need Windows OS, if you need Mac OS, ISO images you can take. Yeah, simply what we can do, take this OS here, hardware is here. Can I deploy my Linux application? Clear now? So clear now? This is possible for what? There is a before layer. This layer is what? Hypervisor. Now two VMs are running on hypervisor, not Windows OS directly. This hypervisor allow to divide your missions logically. Clear now? Same. Now come to here. Now here, do I need to install a hypervisor here? No, this is already VM. Now here, instead of deploy your application on OS, you can take Docker. Clear the concept now? Docker will allow to divide multiple containers. Hypervisor will allow to divide multiple VMs. Whatever you are taking already EC2, right? EC2 means what? Already VM. The background virtualization concept will run or not? You no need to take care of. So you are not starting from the point number 1. This is 1, this is 2, next 3. First evolution is what? Physical server to VM. Next evolution is what? VM to container. Understand? I'm starting from here only. So we no need to focus on these resources areas, right? Why? This is taken care by AWS providers. When I create a EC2, the background resources will take care by AWS. So directly you are starting from VM only. If you go AWS EC2, This EC2 VM or not? This is VM or not? Okay, the background hardware resources will take care by cloud providers. We no need to focus on physical hardware and all. Now this VM, I can divide into multiple VMs or multiple containers. VM to multiple VMs not possible, right? See, physical server to physical server, is there any logic? No. VM to containers are possible. VM to VM means why we need to create VM to VM again? 10 GB VM to 10 GB VM again create means you are increasing the cost. So VM to container you can divide. VM to container means if you connect your VM directly, after that what you can do? Install Docker directly. When you install a Docker, it will give a virtual, isolated environments. This is called containers. Hypervisor will create a server, that server name is VM. Docker will create a server, the server name is container. Understand? Let me write here. I'm writing, just wait, please. The name of the server is VM. By using hypervisor concept, if create a server, the server name is VM. By using containerization concept, if you create a server, the server name is container. Clear here? So possible. So container tools are what? Containerization tools are what now? Docker. So example, Docker. Here examples are what? We have so many examples. VMware, Oracle VirtualBox. Nexaware, correct. Clear what I'm trying to say? A straight question to you. Do we need to take care of virtualization in AWS EC2 if you create? No. Virtualization, not our responsibility. AWS will take care. Containerization? Yes. How we can implement containerization? Just install Docker. Docker will take care. Clear the concept now? Okay. Now tell me, one client is asked you to develop a 100 applications and deploy into 100 applications and give access to release application to public. In this case, you can use Docker. Number of applications count is increasing. Instead of creating each resource for each application, we can implement a Docker. Docker will create a containers. Okay. Now let's focus little bit now. We'll go for the little advanced now. How many applications are running? 10 on Docker, not on OS. Clear now? These 10 containers may be Linux containers, Windows containers, Mac containers also. We don't know, right? This 10 containers running on Docker host. Docker is running on OS. Clear? This 10 container responsibility take care by Docker, not OS. Docker is running OS. Understand? So VM to OS, on VM to OS only Docker is running, not 10 containers. But containers are running Docker. Okay. Now, okay, each container I will explain now. Wait. 10 containers are running, right? And same VM, right? Same VM. Let's take now. Now I need high availability. Means what should I do? Application 1 is running, right? Application 1 is running inside the container, right? But if one container made down, application down, right or not? I need a high availability. What should I do? Create one more application, one container in the same server. In this case, now how many containers are there? Total 20. Clear? Each application 2 copies. Understand? If one container made down, is there any problem? Second container is running already. If app2 is down here, no, second app2 also running here. Clear now the process is? But VM2 down, if VM2 down, all 20 containers will down or not? In this case, what should I do? What should I do? Create one more server. Deploy same containers. Clear or not? Across regions. No, VM2 is not across agent, not across region. Clear the concept? Now tell me, total how many copies, how many replicas are there? 4, right? App1, 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 app1. Total application 4 copies, which is total 40 containers. Is it possible to do manually? How many containers running, how many containers need to run, how many containers need to copy? So I need a well orchestration process. That orchestration process tool is Kubernetes. Understand the process now? This process will take care by Kubernetes. So for time being, you need to understand, okay, what Kubernetes will do, what Docker will do, that's it. How Kubernetes will do, not a correct time to ask. How Kubernetes will create, sir? That's what, wait for 30 days. How Docker will create, wait for 10 days. Process is why Docker, why Kubernetes. Today concept is not how. Okay. If you ask me how, it will take a lot of time to explain. Clear now? So here Kubernetes orchestrated like how many containers required, each container required, and container should create on node means server, okay, which EC2, then okay, which EC2, and all it will take care by your Kubernetes. Okay, so simply I can say high availability response will take Kubernetes. Clear? For suppose one container made down, immediately Kubernetes will create one more container in the same place. High availability. Compare with auto scaling concept. Auto scaling created a 3 servers, for example. Okay. If ASG created 3 servers, if one server will delete, automatically ASG will create one more server, right? That is ASG part. But Kubernetes is ASG for containers. You can understand like that also. Kubernetes is a ASG tool for container level, not server level. Server level also. But Kubernetes na, if VM2 will down na, immediately one more server will create. Kubernetes will take care node level, that means server level, plus container level. But guys, means the background ASG will create. Understand what? See, server level means definitely ASG required, right? That ASG also managing by Kubernetes. Actually, ASG you should manage, right? How many nodes required and all. That ASG also will manage by Kubernetes. Plus, inside server container also will manage by Kubernetes. 1,000 applications are required. How many servers required? ASG, Kubernetes will take care. How Kubernetes will take care? How many servers required? Through ASG. Here ASG managed by exactly ASG configurations and all you can take care, right? But here Kubernetes will take care. Understand? ASG, everything. Node level. Node means EC2. But in Kubernetes terminology point of view, we are not using container, we can use the pod. Name is pod. Kubernetes point of view, we are using pod. Pod plus container 99% same. We'll explain Kubernetes time. What is the 1% difference only? Yeah, Kubernetes alternate tool also there, OpenShift. Kubernetes also I will explain. OpenShift is a alternate tool for Kubernetes. Red Hat provided. Kubernetes developed by Google. So OpenShift developed by Red Hat Enterprises. Hmm? Docker? Docker alternate tool is Containerd. Rocket.D, Containerd. We have but almost 99.9999 Docker only. And these tools also comes from again Docker only. Docker is divided into different tools again. I'm not speaking anything, just giving some time. Okay. So I'm getting messages. Yeah, that's what I'm just waiting. The Telegram group, so I'm checking that. Okay. See, let's go to the chat GPT. You can ask what is containerization. Now you will get a clarity. Containerization is lightweight virtualization technology that packages an application and its dependencies into standardized unit called container. I'll explain what it is. Now. Now focus is on what? Each container. Now very high level we have seen right now. Okay, we have seen right now. We can understand this definition now. What they are saying, containerization is a lightweight virtualization technology that packages an application. Application can package with dependencies into one unit is called a container. Okay. Let's take a now single container. Guys, I'm taking single container now. We have a 40 containers, right? From that list, I'm taking a single container to explain the process in easy way. Otherwise, if you need, okay. So I'm taking any one container. Clear now? So this is app one container. Understand now. So this container, okay, container contains what we can focus. Container also server only, right? I told you, right? Virtual VM also server, container also server, all are servers only, but different, different layers, different terminologies, the background technology. So you can understand sub server or whatever. Server means how many layers are there? Again, same hardware layer. Next layer is what? OS layer. Next is application layer. Clear, right? This is called container only. But the difference, let's take now. Then what is the difference VM and container? What is the difference both? That's what. Size only the difference. Lightweight. Left side is VM, right? Lightweight. Like this, we can change this by only adding the required dependencies. Now tell me, this VM, whenever you can create a VM means what? EC2. Can I say EC2? EC2. Guess whenever you can launch EC2, whenever you can launch EC2, let's go to EC2 now. Okay, let's connect any server. Let's, for example, so guys, I have created a server. I have created a server to just practice Linux commands. Understand like this. Only to practice Linux commands, I have created Linux server. Now, if I give this command, ps aux command is what? Background running, we can say. mlist Java package is there. mlist Python. Python packages are there. Control C. But to practice Linux commands, all these are required. Python, Java, all are required to practice Linux commands, touch command, workdir command. But why these many? By default, they are giving packages. If you utilize, you can, otherwise leave it. But still cost will apply or not. But I don't want this. I don't want this. But sorry, they are giving by default. We can't do anything. That's what the minimum size is 8 GB, something is there, right? But can I apply any customization on EC2 to delete Python packages not required to delete? No, not possible. This is they're giving by default. Okay, my Python application is there. I want to deploy Python application. In this case, your server instead only Python is required. My end Python application is there. To run Python, my end only required Python. Why Java? Why these many processes are running background to run Python? Not required. These are default processes are running, default actions are coming. I don't want these default actions. So if I need only Python to run my Python code. If easy to give the customizing actions, I can delete everything. I can create only Python related Linux EC2 only. But they are not providing, right? If you go to launch instance, they are providing only here. Take whatever OS is required, you can take it only. By default, dependencies will come along with the OS. I don't want all the dependencies, which is, it is increasing the size with the unnecessary dependencies. So this is not possible. That's what we are installing Docker on top of that. First take an instance. On top of that, installing a Docker. Docker will provide a containers. Now focus is what? Container. Then same container means what? Like a server only, right? Like container also, 3 layers will be there or not? Container also 3 layers are right or not? But this is small server. Understand? Server childs, small server. But here, required OS are not required. Required hardware are not required. Okay. This container size, we can decrease, we can increase. Customizing. That means customizing. How to customize? Let's move like this. VMOS providing by AWS with all dependencies. But whenever you can create container on EC2 OS, this container is your wish. You can customize by using Docker. How to customize? This OS will take from this OS provided from where? AWS. AWS AMI, right or not? If this is AWS EC2, na, this OS will get from AWS AMI. If this is on-premises server, This OS we can download from the Google, Ubuntu OS and all. Okay. But this OS, tell me, container OS depends on the host OS or not? Does container OS depends on the host OS or not? This is my question. Hmm? You tell me, virtualization OS depends on the host OS or not? My question is very clear. Container virtualization application sharing host OS or not? Only hardware, not OS. Otherwise, Linux application, how it will share Windows OS? This is clear, right? Only sharing hardware. How physical server to virtualization server is coming, same virtual server to containers are coming. But containers are same, not sharing OS to host OS. How VM OS is not sharing host OS, physical OS, same container OS also not sharing from EC2 OS. Clear or not? Then from where we can take OS? Here Amazon AMI is giving. On premises means taking from the Google, but this is container. Runs on where? Docker. Runs on where? Docker. Means this container, can I say, running on the Docker? Running on the Docker. Clear, no? This container running on the Docker. So this container's creation will take care by Docker host, right or not? This Docker running on EC2 OS. Clear the concept? This Docker running on EC2 OS. Let's take now a big virtual machine now. Clear the concept now? This VM also we have a OS, right or not? Clear or not? Now, this VM having hardware or not? Hardware. This hardware, container hardware only shares from host hardware, but not container OS will share from host OS. This is not correct. Clear or not? This is not correct. Then OS need from somewhere, right? That is called Docker Hub. OS we can share from Docker Hub. Let's go to Docker Hub. So what Docker Hub is saying here, what Docker Hub is saying that you need OS, right? Okay. We will provide the required OS. Which OS you require to run this application? Which OS you require to run this application? Ubuntu, for example. Okay. We will provide Ubuntu. Focus first. First focus first. Why you are going for GitLab, GitHub and something? I don't know who is sending that messages. I'm unable to see the names. While I'm explaining something, only I can see message only, not name. Okay. Now, to run this application, I need OS. Which OS? For example, Ubuntu OS. Okay. In this case, Ubuntu OS you required, right? Okay. What Docker Hub is saying, we will provide that OS. You no need to go to any Google and all. We will provide. If you take Ubuntu from Google, there is a difference. What is the difference? I will show you. Wait. I will show you. Wait. The difference is what? If you take Ubuntu from the Google. Let's go to here. Let's go to here. This is internet, for example. This is internet, for example. If you take Ubuntu from here, if you take Ubuntu from here by using Google and all, size difference. Yes, exactly. If I go to Google, I need Ubuntu file, Ubuntu file. They're giving what is the size. Yeah, let's go to Ubuntu download desktop here. Yeah, I can see minimum size is 6 GB. This Ubuntu contains lot of dependencies that not required for us. But customizing not possible here. You have to stick on 6 GB or 8 GB. But here Docker is saying, that's what I'm saying, that you don't take from Google. I will provide whatever image is required. You need Ubuntu only, right? Yes. Take this Ubuntu from Docker Hub. The benefit of this Docker Hub only, you need only Ubuntu, right? We will provide only Ubuntu, not any dependencies. So let's go to the Docker Hub now. Instead of taking Ubuntu on Google, let's take from the Docker Hub now. Let's take from the Docker Hub now. See, go to Docker Hub. Now check this image size. What is the size of image? Just 20 MB only. See the image, 6 GB to 20 MB. The difference is what? Only 20 MB, guys. Only 20 MB. That means I'm just reducing the image size by taking Docker help. If you reduce the image size, can I create multiple containers? 6 GB to 20 MB, the difference, how many containers we can create? Hundreds of containers I can create. But both are Ubuntu's only. Then what is the difference? Here Ubuntu is 6 GB, having lot of dependencies. Those are not required for us. Clear or not? Okay. Now this application is Python application, for example. Okay. You need what only? Only need Python. So install Python only. That means this is called packages. Where on 20 MB OS, install Python. Now this size may be increased to maybe 100 MB. But not 6 GB, right? Yes, maybe 100 MB. Plus Python, maybe 100 MB. Clear now? So if you reduce the size, the main benefits are what? Main benefits are what? Tell me first. Tell me, guys. Okay, you are saying, everyone is saying costing, right? Costing, lightweight. Okay, lightweight. Okay. Next, the main important thing, the main important thing is quick access application, quick run, lightweight, less dependencies means easily can start your application, quickly start your application, quick action. Why? Less dependencies. Can I say performance also more? Good performance. Python application to run Python dependencies only need I have installed. Done. Run. Running 6 GB application, running 100 MB application is difference is there, right? Running 100 MB application quickly can start compared to running 6 GB. There are a lot of dependencies. The dependencies you can see here. See, so many dependencies are there. Let me show you simple lab in 2 minutes only. You don't focus if you're unable to understand, as this is first class. Just understanding what is Docker today class is. Okay, simple logic. If I want to deploy multiple applications, I will take a Docker help instead of creating multiple servers. Cost can reduce, and architecture, process managing will be reduced. Okay, now this is a single VM, right? If I want to work with Docker, what should I do first? Install Docker, simple logic, install Docker, m install. That's it. I'm installing Docker. See this architecture now. Docker installing on where? EC2 OS, right or not? No. By using m install Docker. Where this EC2 is running, how this EC2 sharing hardware, not our responsibility. For example, guys, you tell me this entire EC2 inside how many containers are running now? Only one container, huh? But this EC2 runs on where? Huh? This EC2 run on where? Cloud providers will take care. Take care by AWS hardware resources. You no need to take care. That means cloud providers will take care. But this VM runs on your mission. You can take care this hardware and all, right or not? So EC2 OS taking care by cloud providers. EC2 hardware taking care by cloud providers. Containers hardware taking care by EC2 hardware. By increasing the EC2 hardware, can I increase the containers hardware? Yes. But this hardware will give by AWS hardware providers. For example, my end, this server is there, right? This server already running now. Let's go now instances. Click on this. So I can increase the instance type. I can increase the storage now. If you increase the storage 8 GB to 10 GB, that means they are giving 8 GB to 10 GB. Whenever you can increase the size here, container also will take more hardware. Clear or not? What I'm trying to say. Yeah. Now see here, Docker already running my end, right? Docker already running my end. So I'm going to take an image from the Docker. The image is what? Ubuntu image. So the command is just Docker pull Ubuntu. Okay, let me start Docker now. You don't need this practice, just understanding purpose only. I will discuss, the actual class will start after Azure. Again, very high level, just I will give you the 15 minutes. I will start the process. Okay. So we will discuss here many Docker files, 20 Docker files. It's not like Docker is very high level. We are not going to discuss. In depth, we can go. Multiple stages, performance, volumes, networks, compose, SWAM, lot of concepts are there. I will take care of everything. Docker troubleshooting. Then we can Docker with Jenkins, Docker with GitLab CI/CD if required. And then we can go for Kubernetes. Okay. Let's start now the process. So this Docker automatically will pull the Ubuntu. This is public images. Image is running, right? So this image, if you can run as a container. Simple how to run Docker run only. Docker run, give the image. Image name is what? Ubuntu. Docker PS, if you can see. Okay, let's run Docker run Ubuntu -it bin bash. Okay. Yeah. Let's give here Ubuntu later. I'm inside of container now. Understand? If I'm inside of container, why I'm trying to show you here. If I give ps aux command, before I could see so many processes are running, right? How many processes are running now? Only 2. Understand the difference? Container inside only 2 processes are running. But before EC2 inside, see these many processes are running, right? Lot of dependencies are there. This is only less dependencies. Okay, you took only Ubuntu process is running. Next, if I install Python, Python process run. Ubuntu plus Python, 3 process. No less, more dependencies. Understand the difference now? Okay. So this is introduction only, and the official classes will start. I will show different process also. Okay. Yeah. Thank you so much. Bye bye. If you are having any questions, ask in the group regarding Docker. Okay. Thank you. Thank you. Are you able to understand at least 2%, not 100%? Yeah. Not easy. Oh, 80%. Great, great. 90, huh? Okay. Great, great. Yeah. Bye, guys. Yeah.